Picture the universe as a photograph. To the human eye, the main event is the light, the bright, solid matter of stars and galaxies scattered across a vast, dark, empty void. Now, invert it. In this perspective, the voids are dazzlingly bright. The intergalactic space and quantum vacuum become a blinding, turbulent field of active noise, while the matter we once called everything becomes a collection of dark, rigid islands. For 400 years, we have documented the dark parts. Our physics and our cosmologies have focused almost entirely on these rare, localized pockets of order, treating the surrounding space as a quiet stage for matter to inhabit. But the void is not an absence. It is a continuous, physically self-interacting field of noise that dwarfs the stars in every dimension. Every particle and force we know is a temporary pocket of order flickering against this background. By focusing on the islands, we have spent centuries staring at the shadows on the wall and calling them the fire. If reality is actually a sea of chaotic physical randomness, we have to explain why it looks so structured. Where did the geometry of our cosmos come from? In a system where noise is physical, the components collide and interact. This friction creates non-linear dynamics that inevitably funnel chaos into stable, self-reinforcing patterns called strange attractors. The turbulence carves out its own internal order. In this framework, the Big Bang represents the vertex of a massive attractor event, the specific point in the noise where the whirlpool is most tightly wound. It is the moment of maximum localized order and minimum possible states, a convergence point for the surrounding chaos. What we perceive as an expanding universe is the relaxation of that geometry. The focused order of the vertex is disseminating back toward the noise. The expansion accelerates as the background turbulence begins to reclaim its own. The universe we inhabit is the necessary geometric consequence of what infinite noise does when left to interact with itself. Within this cosmic whirlpool, smaller engines of order emerge: stars, cells, and minds. We can call these structures kinetic machines. These machines maintain their internal order by processing the noise across a boundary. They draw in structure and pump out disorder, exporting entropy to keep their own internal configurations intact. We treat time as a spatial coordinate, a fourth dimension on a graph. But every clock we build, from the gears of a watch to the oscillations of an atom, measures physical change. This change is the exhaust of the sorting process. Time is our name for the rate at which a kinetic machine's boundary processes order and disorder. Where no sorting happens, where a system is in perfect equilibrium with the noise, there is no measure of change. Time only exists as an activity of the boundary. It is a byproduct of existence, not a container for it. If we are just churning thermodynamic processes, why does the world appear so stubbornly solid and discrete? This is Claude Shannon, who defined information as unpredictability. In his math, pure noise carries the highest possible information density. The background of the everything is so full of data that it contains every configuration simultaneously. Human biology has finite bandwidth. To survive within this infinite information field, our nervous systems must heavily compress the signal, filtering out the overwhelming majority of the noise. The discrete quanta and solid particles we observe are the results of this compression. They are pixel artifacts of our own resolution limit. We perceive a world of sharp edges because our instruments lack the bandwidth to see the continuous, turbulent depth. Our laws of physics describe the compressed signal. They are an efficient map for the mind, even if they cannot capture the raw texture of the territory. What happens if we try to dive beneath the map, looking for the final, indivisible bottom of reality? Because the noise is continuous, it has no floor. As we zoom in, the supposedly solid particle reveals its own internal landscape. It is an infinite fractal, showing new islands of order and seas of noise at every level of resolution. Without our compression limits, the interior of a subatomic particle is as complex and deep as the entire observable cosmos. This is scale relativity. The dynamics that produce the cosmic web are the same dynamics that operate at the sub-Planckian level. The macrostructure is mirrored in the micro because the self-interacting noise is the same at every scale. There are no fundamental building blocks. There is only an infinite depth of turbulence. In the standard story, we are fragile accidents, unlikely glitches in a dead, indifferent void. In the inverted universe, we are the inevitable expression of the medium. We are localized configurations of the noise itself. We are the geometric response to the gradients in the everything, shaped over billions of years of attractor dynamics. Every thought is a local act of sorting, taking the signal from the static to maintain our boundaries and generate new structure. We are the everything sorting itself out. We are the noise temporarily organized into a shape that can look back at the chaos and wonder at its own existence.